Hey guys, today we're going to be simplifying radicals. So before we start simplifying, we have to know what they are. If b squared is equal to a, then b is a square root of a. So pretty much when we're saying radicals, you should be thinking of square roots. All positive real numbers have two square roots. All positive real numbers have two square roots. Now, there are a few things in there that are pretty important to think about. One, they have to be positive. So if I take the square root of a negative number, say for example, square root of negative 16, that is actually an imaginary number. So since I would make it imaginary, that means it is not real. So we're only looking at our positive numbers here. And then also they have two square roots. So if I look at the square root of 16, you could say that that answer is equal to 4. However, you could also say it is equal to negative 4. Because if I square either of those numbers, both of them should equal to 16. 4 times 4 is equal to 16. Negative 4 times negative 4 is also equal to 16. So a lot of times if I'm asking for the square root of something, we could say plus or minus 4. Now the number inside of the radical is called the radicand. Just to show some kind of symbols, when we have a positive square root, it just looks like a regular square root. You don't have to put positive in front of it. My neighbor's truck is so loud. I hope you guys can still hear me. If we're talking about a negative square root, that's when you have the negative sign out in front of it. And if we're looking at the positive and negative square root, you'll see the plus or minus sign in front of it. So some examples, if you just see the square root of 9, you can expect to just get the answer 3 back. If you're looking at the negative square root of 9, you can expect the answer negative 3 back. But if you get plus or minus the square root of 9, you can expect to get plus or minus 3, or positive 3, or negative 3. Those are all cool things. All right. Getting into properties. So the product property of radicals. The square root of a product equals to the products of the square roots of that factor. So for example, if I have the square root of AB, that is the same thing as the square root of A times the square root of B. So I'm just splitting up those two factors and then taking the square root of both of them. And this is true from when A and B are greater than or equal to 0. So again, any of my positive numbers, and 0 can be included for both of them. And we can look at this. For example, does the square root of 36 equal to the square root of 4 times the square root of 9? Well, we know that the square root of 36 is equal to 6. The square root of 4 is 2. The square root of 9 is 3. 4 times 9 does equal 36, and 2 times 3 does equal to 6. So it is true. For the quotient property of radicals, the square root of a quotient equals to the quotient of the square roots of the numerator and the denominator. So if I have the square root of the quantity A over B, that is equal to the square root of A divided by the square root of B. where a is greater than or equal to 0 and b is greater than 0. B cannot equal to 0 because that means we would have 0 in the denominator, and that's the U word. We don't want that. And again, we can look at this. If I had the square root of 81 divided by 9, that should be the same thing as the square root of 81 divided by the square root of 9. Well, 81 divided by 9 is equal to 9, and the square root of 9 is equal to 3. We just said the square root of 81 is equal to 9, and then the square root of 9 is equal to 3. 9 divided by 3 is 3. They check on both sides. Now, actually going through and using these properties to simplify radicals. An expression with radicals is in its simplest form when no perfect square factor other than 1 are in the radicand. So for example, if I have the square root of 8, I can split that up to 4 times 2. So I'd have square root of 4 times 2. Which would be the same thing as the square root of 4 times the square root of 2. Well, I know what the square root of 4 is. That's 2. But I don't know what the square root of 2 is. So I'm leaving that as the square root of 2. Now, looking under my square root, can I factor that down anymore? Are there any numbers I can pull out that are perfect squares? No. 2 is a prime number. It stays as 2 root 2. There can't be any fractions in the radicand. So we really have to make sure we're using that quotient property of radicals to make sure that there are no fractions inside. And then no radicals can appear in the denominator of a fraction. So we are going to have to rationalize our denominators here. And we'll see that down below. So when simplifying our radicals, big thing, see if you find any perfect squares. We should all know our perfect squares at this point. So when looking at the square root of 50, what perfect square can go into the number 50? Immediately, I'm thinking of 25. I can take 50 and divide it by 25 and get 2. So now I'm going to find out what the square root of 25 times 2 is. Well, because of my product property, I can split those two numbers up, giving me the square root of 25 times the square root of 2. Square root of 25 is equal to 5. I don't know what the square root of 2 is. So I'm just going to bring him down. Now looking at the square root of 2, are there any other perfect squares I can pull out from that? No. 2 again is a prime number. Square root of 50, when simplified, is equal to 5 root 2. Let's look at 48 together. All right, trying to think, what is a perfect square that can go into 48? Well, an easy one would be one of the beginning numbers, right? I can take a 4 out. So really, the square root of 48 can be rewritten to be the square root of 4 times 12. Which I could then rewrite to be the square root of 4 times the square root of 12. The square root of 4 is equal to 2. I don't know what the square root of 12 is. All right, now looking at this, can I rewrite the square root of 12 now? Well, you can, because I can take another 4 out from 12. So really, this would be 2 times the square root of 4 times 3. Rewriting that, I'd have 2 times the square root of 4 times the square root of 3. Square root of 4 is equal to 2. 2 times 2 is equal to 4 root 3. Now, if you wanted to, if you saw in the beginning, you could have taken out another number. It seems like the square root of something else can go in there. What is it? Can 16 go in there? It seems like 16 could have come out of that. That's pretty nice. But again, if you don't know that, you can take these individual steps. So square root of 48 is equal to 4 root 3. I want you guys to try out these two. So pause the video, figure out what the simplified form of square root of 63 and the square root of 20 can be. Did you pause it? Did you pause it? Alright, I hope you paused it. If you didn't, you lied to me. So with 63, a perfect square that can go into that is 9. So I can rewrite that to be the square root of 9 times 7, which should then be rewritten into the square root of 9 times the square root of 7. The square root of 9 is equal to 3. We don't know the square root of 7. It's a prime number. My answer is 3 root 7. Ooh. 20. I can take a 4 out. So this can be written as 4 times 5. Or the square root of 4 times the square root of 5. Square root of 4 is equal to 2. Don't know the square root of 5. It's a prime number. Square root of 20 is equal to 2 root 5. Alright, down here. Getting into fraction territory. Again, the big things is we don't want a fraction inside the radical. We also don't want our denominator to be a square root. So the square root of 3/4 can be rewritten as the square root of 3 over the square root of 4. Once when you have it here, now you have to simplify the top and the bottom. Well, 3 is a prime number, so nothing can be pulled out from that. So we could just keep that as the square root of 3. The square root of 2, we know. That's a perfect square. That's equal to 2. So the square root of 3/4 can be rewritten as root 3 over 2. Yo, if you guys can hear like these dogs barking from next door and like people cutting grass, I'm so sorry. But I'm not closing my window. It's too nice out today. I need that fresh air. All right. The square root of 7/16. Same deal. Take the square root of the numerator, square root of the denominator. 7 is a prime number. That's just going to stay root 7. And then we know what the square root of 16 is. It's 4. So the square root of 7/16 can be rewritten to be root 7 over 4. All right. Looking at this next one, I have the square root of 32 over 50. Now, there are two ways that we can actually do this. And I do want to show you both ways. So we could just go ahead and look at them and say, okay, what's a number that can go into 32 and 50? And we can just start trying to simplify that fraction before we start going into our square root territories. Well, 2 can go into the top and bottom. So really, I would have, 2 times 16 over 2 times 25. Those 2's can cancel each other out, giving me this boy. And then from here, I can easily just rewrite it to be the square root of 16 over the square root of 25, which would equal to 4/5. But there's another way we can also go with it, of course. We can look at the square root of 32 over the square root of 50. rewrite these guys to be the square root of 16 times the square root of 2, the square root of 25 times the square root of 2. We know that these guys are 4 root 2 over 5 root 2. And then simplifying my fraction here, seeing that the top and bottom both have a square root of 2, they would cancel out, giving me 4 root 5. So from this one right here, again, we can just go the easy route. Both top and bottom can be divisible by 10, giving me 4/9. Square root of 4 over the square root of 9. My simplified radical is just 2/3. All right. Getting close to the end. I have the square root of 20 over 4. So I have a radical up in the top that needs to be simplified. So we try to think of a number that can go into 20, preferably a perfect square. So that could be rewritten to be 4 times 5 over 4. We'd have the square root of 4 times the square root of 5 over 4, which can be simplified to 2 root 5 over 4. Now, if you gave this on the test, I would take points off because your fraction is not simplified. You see at the top, we have a factor of 2, and we can rewrite the bottom to be 2 times 2. So I can take a 2 from the top and bottom. The final answer here would be root 5 over 2. Looking at that same thing in this next one, I can rewrite the square root of 18 to be the square root of 9 times 2 over 3, or the square root of 9 times the square root of 2 over 3. We know that the square root of 9 is equal to 3. We don't know what the square root of 2 is. 3 on the bottom. Again, there's a factor of 3 on the top and bottom. They would cancel each other out, giving me the square root of 2. All right. Tomorrow, you guys will be practicing simplifying radicals. Let me know if you have any questions. Okay.